Hello, welcome to Life Sciences Today. We're going to be spending quite a bit of time today looking at the idea of extinction and in particular mass extinctions. So, I hope you're ready. An organism, you should know, goes extinct when there are no individuals of that particular species left alive anyway on Earth. Now, paleontologists have discovered that there have been times in history of the Earth. Remember, previously we looked at geological time. There have been periods when many species died out or went extinct at the same time. And these have been called by the scientists mass extinctions. Not just one or two different species going extinct, but lots of different species all going extinct within the same time period. And we can table these mass extinctions, and scientists have recorded about 5 of these major extinction periods. Usually the causes can be determined that at that particular time, for example, the end of the Ordovician period, there were climate changes, possibly an ice age with a drop in the sea level. This is thought to be the second biggest extinction event. The end of the Devonian period, a little while later, a little while meaning kind of 100 million years later, another mass extinction. And at this particular time, very similar climatic conditions. End of the Permian period, once again, climatic changes, an ice age, and enormous volcanic eruptions. This, at the end of the Permian period, is known as the biggest extinction event ever. Reptiles actually replaced amphibians as the dominant group. At the end of the Triassic, dinosaurs dominated and were not actually affected by that mass extinction. However, at the end of the Cretaceous, all the dinosaurs went extinct. It is thought that there was a possible meteorite collision with Earth. At this time, importantly to us, mammals increased and became the dominant group, replacing the dinosaurs that went extinct. So scientists have looked at these periods of mass extinction, and they have noticed that mass extinctions tend to accelerate or speed up changes in life forms. And that kind of makes sense with what we've been looking at previously in terms of evolution happening in a population. We know that populations evolve when environmental circumstances tend to change. And I'd say an ice age or volcanic activity is a pretty serious change in environmental circumstances. And so therefore it makes sense that if environmental circumstances are changing, we're going to see a speeding up, a more rapid speciation and evolution of populations over time. Another thing that scientists have noticed is that there is a time period after the extinction event, of course, that biodiversity decreases. Remember, biodiversity being the number of different species that we can count. And obviously, if there's an extinction, that number of species is going to decrease. But what they've also noticed is, after a period of a couple of million years, there is a burst of adaptive radiation and speciation. It's almost as if the organisms that were dominant at that particular time of the extinction left space for all these new organisms to fill their niches in the different environments. Scientists have also noted that a different group of animals usually becomes dominant after an extinction period than was dominant before. Remember when we looked at our table? At the end of the Cretaceous, we had the dinosaurs being the dominant group of organisms becoming extinct and mammals taking their place as the dominant life forms. It seems like when this dominant group is eliminated from the environment, a whole lot of ecological niches become free, which another group can infiltrate and fill those niches, and therefore, if they're successful, become dominant. Mammals, especially large ones, I think you probably are familiar with mammoths, could not compete against huge dinosaurs during the Cretaceous period. But at the end of the period when the dinosaurs went extinct, this left all those niches for large organisms, and the mammals increased rapidly in diversity as they occupied those empty niches. Now, what causes an extinction? Of course, scientists can't be sure because they happened so long ago. But by studying evidence that grows and grows all the time, they can put forward a number of different theories. And it's highly likely that a combination of events leads to a mass extinction. Ice ages, continental drift, plate tectonics, earthquakes, volcanic activity, all tend to lead to the idea of us thinking about mass extinctions. Now, after the break, we'll look at some more ideas.